Jake Sully?
I'd like to talk to you about a fresh start on a new world. You'd be making a difference.
I became a Marine for the hardship. I told myself I can pass any test a man can pass. All I ever wanted was a single thing worth fighting for.
Ladies and gentlemen, you are not in Kansas anymore. You are on Pandora.
You should see your faces.
We have an indigenous population called the Na'vi. They are very hard to kill.
This is why we're here.
Because this little gray rock sells for 20 million a kilo. Their village happens to be resting on the richest deposit, and they need to relocate.
Those savages are threatening our whole operation. We're on the brink of war, and you're supposed to be finding a diplomatic solution.
The concept is to drive these remotely controlled bodies called avatars. They're grown from human DNA, mixed with DNA of the natives.
Marine in an avatar body. That's a potent mix. You get me what I need, I'll see to it you get your legs back. Your real legs.
Hell yeah, sir.
Looks like you. This is your avatar.
Just relax and let your mind go blank. It shouldn't be hard for you.
Jake, it's real simple. I want you to learn from the inside. I want you to gain their trust.
You should not be here. Go back. All this is your fault.
I need your help. Outstanding.
Haven't gotten lost in the woods, have you?
Did you forget what team you're playing for?
Strong prey on the weak, and nobody does a thing.
You've got 1 hour.
You knew this would happen?
Everything changed. Jake, it's crazy here. Quaritch is rolling and there's no stopping him.
We're going up against gunships with bows and arrows.
Well, I guess we better stop him.
I'm Jim Cameron. In Avatar, we showed you a planet in peril. Here on Earth, our species is learning how to care for our home. NASA's Eyes in Space enable unparalleled insights into our planet's health. And with this knowledge comes a profound responsibility to act when something is wrong. NASA science helped detect the hole in our sheltering ozone layer and diagnose its cause. Now NASA is monitoring the Gulf oil spill to help the science community better track and understand what we face ahead in dealing with this catastrophic situation. Learn more about how to take care of our own planet, Mother Earth.
In the movie, their deity that these giants worship is referred to as Iwa. Where do you guys think that name came from? Iwa. Iwa comes from the word Awa, which comes from the word Awas. Awas, and I don't know if I'm pronouncing it correctly or not, but Awas is a mysterious being summoned by Alistair Crowley and his former mentor. It's often called under the code name of Dragon, but also referred to itself as something similar to an angel. Guys, Awas is Lucifer, the same Lucifer, or at the very least demon, that Alistair Crowley communicated with. And you can believe what you want, alright? But Alistair Crowley really did communicate with demonic spirits. So we have this planet that represents Saturn. We have these indigenous giants who represent demons worshiping the planet, which represents Lucifer. and they even call this satanic deity by name.
Pandora, a world of wonder and mystery, incredible danger and strange beauty. From Earth's southern hemisphere, you can see the solar system where Pandora is located. Alpha Centauri. At a distance of 4.4 light-years from Earth, the Alpha Centauri system is our nearest stellar neighbor. The largest of its two sun-like stars, Alpha Centauri A, or ACA to astronomers, is Pandora's sun. Pandora is one of many moons orbiting the planet Polyphemus, a gas giant planet the size of Saturn. Pandora's toxic atmosphere makes it uninhabitable by humans. Tropical rainforest covers a large part of each of the continents. These rainforests are similar to those that once covered the Amazon basin, but on a scale several times the size of anything on Earth. Perhaps the best symbols of this relationship are small luminescent wood sprites, which are the seeds of the Vitraia Ramunong, the Tree of Souls. The tree is sacred to the Na'vi and believed to be the heart of the deep connection of all life. Pandora. One can only think of its namesake in Greek mythology. The box has been opened. Amidst the savage terrain and fierce creatures, we must assume this strange, bewitching place might hold something inside itself for us all. Hope. For our race, for our planet, and for the future of all living things.
In recent years, researchers have seen an alarming warming trend in the global climate. Reports of increasing temperatures, thinning glaciers, and rising sea levels have led to widespread speculation that global warming is being caused by greenhouse gases that result from man's activities. Climate models that predict the Earth's future climate patterns indicate that global warming could continue to increase if the concentration of greenhouse gases in the atmosphere continues to rise. Even though these climate models are powerful tools in predicting future global climate, a more detailed understanding of clouds and aerosols could lead to more accurate climate prediction models. Researchers may be able to determine why the climate is warming, if it is being affected by greenhouse gases, and what we can do to change it. That is why researchers at NASA are preparing 6 innovative satellite systems, which when launched will provide key information about the Earth's atmosphere. 2 of these satellites, Calypso and CloudSat, will focus primarily on aerosols and cloud structures, providing much more information about how clouds and aerosols interact with each other and how they're affecting the atmosphere's radiation balance. I spoke with Lamont Poole at NASA Langley Research Center to find out more.
It's important to study clouds and airborne particles, which we call aerosols, because both of them have significant effects on the Earth's climate, just like greenhouse gases such as carbon dioxide. But unlike greenhouse gases, which warm the planet, airborne particles and clouds can either have a warming effect or a cooling effect, depending on their type and their altitude. Because of these complicating factors, it's very difficult to represent cloud and aerosol processes accurately in climate models that are used to forecast the climate in the future. So the data that we will be collecting from CloudSat and Calypso will provide a much more accurate picture of cloud and aerosol processes.
So what are the differences between the Calypso and CloudSat satellites?
They're going to be launched on the same rocket, and when they get to altitude, they will separate into different but very closely matched orbits. In fact, as Calypso and CloudSat orbit the Earth, they will be within 10 to 15 seconds of each other in their orbit. CloudSat and Calypso are going to be flying as part of a formation of satellites that's called the Afternoon Constellation, or the A-Train for short.
The A-Train will actually consist of 6 separate satellites flying in close proximity to one another. Once in orbit, each satellite will cross the equator within minutes of one another, taking specific atmospheric measurements. Although each satellite has a unique mission, the data retrieved will be combined together, providing detailed observations about the condition of Earth and assisting scientists with making predictions related to climate change. By combining information from the different satellites, scientists will be able to gain much more information about the condition of the planet than they could from any single mission alone, greatly improving prediction capabilities. Once these systems are in place, what do you hope the outcome will be?
Our ultimate goal is to provide accurate scientific information to decision makers and governments worldwide so that informed and balanced decisions on how to mitigate or adapt to climate change can be made. And NASA is going to play a very crucial role in this process because of our capabilities in developing and flying new technologies such as Calypso and CloudSat.
If you're like me, you've heard a ton about global warming and global climate change, but you may not necessarily know what global warming is or what it really means. Let me try to break down parts of it for you.
The Earth's atmosphere is comprised of many different types of gases, like oxygen, nitrogen, carbon dioxide, and others. These gases have been in our atmosphere forever. But since the beginning of the Industrial Revolution, when humans started burning fossil fuels and emitting so much pollution, a change in the balance of gases in the air began to occur.
And when these levels started changing, something called the greenhouse effect intensified. Now, the greenhouse effect isn't necessarily a bad thing by itself. It allows Earth to stay warm enough for life to survive.
It works like this. When the sun's rays hit the atmosphere and the surface of the Earth, approximately 70% of the energy stays on the planet. The other 30% is reflected into space by clouds and other reflective things. But even the 70% that gets through doesn't stay on Earth forever. Eventually, it gets radiated out. Some of this heat makes it into space, but the rest of it ends up getting absorbed when it hits things in the atmosphere, like carbon dioxide, methane gas, and water vapor. But a major problem in recent years is that more heat is staying on the planet and can't get through the increased level of gases. Now, this doesn't sound like such a bad thing until you realize that even small changes in the planet's temperature can cause really bad things to happen. For example, ice melting in our polar regions. If the ice melts, some coastal regions, like parts of Florida or New York City, could potentially be swallowed up by the oceans, displacing hundreds of millions of people.
Scary stuff. But luckily for all of us, we have researchers all over the world monitoring the Earth's atmosphere, trying to figure out what's going on with it. Now, one of those scientists is Dr. James Hansen of NASA's Goddard Institute for Space Studies. A key objective for Dr. Hansen and his crew is the prediction of atmospheric and climate change in the 21st century. Now, I went to meet Dr. Hansen near his office here in New York City.
Dr. Hansen's office is located just above the famous Tom's Diner from the Seinfeld show, but I spoke with him on the campus of Columbia University.
Well, the big issue that has come up in the last several decades is the fact that humans have now become a big player in the Earth's long-term climate. You know, scientists had thought that the Earth is so large that it's very hard for humans to impact the natural system.
It's so large that it's very hard for humans to impact the natural system.
But it has become very clear that humans are now having an effect. And primarily that's through the added gases that we've put into the atmosphere, especially by burning fossil fuels. That's oil, coal, and gas. And that releases carbon dioxide and other gases and small particles, and these affect the energy balance of the Earth. The gases trap infrared heat radiation, so that it tends to make the planet warmer. The planet has to warm up enough to keep the amount of energy going out from the planet equal to that coming in. And the result has been a warming of about 1.5 degrees Fahrenheit in the last 100 years. And we can see that there's more warming in the pipeline. You know, 1.5 degrees doesn't sound like much compared to weather fluctuations, which are 10 degrees or even more. That's fairly small, but it's enough to begin to have some long-term effects.
So what is NASA's role in your research?
Well, it's natural that the home planet is a place that NASA has been looking at from space for a long time. For example, there's just a remarkable satellite that was launched a few years ago called GRACE. It's the gravity satellite. Okay. It measures the gravity field of the Earth with such a high precision that we can see the change in the mass of the Greenland ice sheet or the Antarctic ice sheet and other things. Well, what we see is that sea level is now going up at about 3.5 centimeters per decade, which is, you know, in a century would be about so much. That's more than a nuisance, but the danger is that it could get to be much larger than that. If we keep adding more and more greenhouse gases to the atmosphere, the rate of melt will increase to the point that the ice sheet begins to collapse. And if that happens, sea level could go up several meters, which would be a worldwide disaster. Therefore, we need to figure out how these ice sheets work, and we need to figure out how much warming they can stand before they begin to collapse. That's the kind of thing which we can study with the kind of measurements that NASA is making.
Can we stop this process, or
can we stop global warming?
Can we at least slow it down?
We can do it. We could even stop it, not just slow it down, but it's not easy. Right now, the planet is out of energy balance with space because of these added greenhouse gases. So if we wanted this planet to stop warming up, if we wanted the Arctic ice to stop melting anymore, then we would have to restore this energy balance. Now, we could do that. So if we would decide, okay, let's really make a strong effort to reduce this air pollution, the things that damage human health, we could actually restore energy balance on the planet and stop the warming. But, you know, it's not going to happen unless people begin to ask for it to happen.
Unless people begin to ask for it to happen.
All right, so what are some of the things that NASA is going to be doing to help with the prevention of global warming?
Well, I think the most important thing is to continue and expand global observations. Okay. For example, although we have good measurements of greenhouse gases, we don't have good measurements of the small particles in the atmosphere. The sulfates and black soot, small particles that are produced mostly in fossil fuel burning also, but they reflect sunlight or absorb sunlight, and that affects the climate just as well as greenhouse gases do. And you know, we're working on instruments that can do a better job of that. But we also need to continue measurements such as the gravity satellite measurements of the ice sheets, because it's very critical to understand how much warming they can stand before they begin to collapse. So we have to keep our eye on the planet Earth and really see what's happening.
Cool. So Dr. Hansen has explained how NASA is helping us recognize what's going on to our Earth. But what can we do to help? Well, we can do small things like use energy-efficient appliances and light bulbs.
And we can recycle and seal any areas in our homes, like doors and windows, that allow heat to escape. You can unplug so-called vampire electronics, like cell phone chargers, that suck electricity even when they're not being used.
And there are tons of things that we can do every day. We just have to start being smart about it. Other than power plants and industries that put so much pollution in the air, there is one other major source of pollution out there. The car.
The car.
Cars pump millions of tons of pollution in the air every day, but we gotta get around, right? So what are we gonna do about it? Well, in big cities like here in Manhattan, you can take public transportation, like the subway. Or you can take buses, hybrid cabs. Yo, taxi! You can even bike or walk.
Stand up for